What's up everybody, my name is Moss, and welcome back to this tutorial series on GitLab. We have familiarized ourselves with the GitLab interface and are now comfortable using the GitLab flow, but we're still not using some of the most important features the GitLab platform offers. In today's world, just about every codebase is supported by a continuous integration and continuous delivery/deployment pipeline. Let's take a look at the features related to CI/CD that GitLab offers for its projects. In this video, I'm going to show you how to perform CI/CD in GitLab. Let's review our learning objectives for this module. After completing this module, you should be able to do the following. Demonstrate an understanding of how GitLab pipelines integrate with a GitLab project. Implement GitLab pipelines in your own GitLab projects. Write a GitLab pipeline that produces artifacts. Write a GitLab pipeline that caches dependencies. Write a GitLab pipeline that uses variables. And finally, describe the anatomy of a GitLab pipeline. Let's define some important GitLab CI/CD terminology. The first is a GitLab pipeline. A pipeline is a top-level component used to define a CI/CD process for a GitLab project. And within a pipeline, we can define stages and jobs. Next, we have jobs. Jobs are associated with stages within a pipeline, and they define the actual steps to be executed, such as running commands to compile code. Then we have stages. Pipeline stages define the chronological order of jobs. And finally, we have GitLab runners. GitLab Runner is an open source application that executes the instructions defined within jobs. It's a program that can be installed on your local machine, a cloud server, or on-prem. Shared runners are hosted by GitLab. Now that we've defined these concepts, let's get started. Okay, so the first thing that I want to do is quickly walk through the code base that we're going to be using. I've created this GitLab project called Sample Maven Project, and it's a very simple Maven code base. And it's actually based off of a code base that you can automatically generate from a tutorial by Maven. And if you simply search Maven in 5 minutes in your browser, the first link here, Maven in 5 minutes, has a tutorial where you can generate the same project. So under this section, creating a project, I generated this code base using this command. So it creates a project of Maven archetype quick start. So let's take a look at that code base in GitLab. If I exit out of the tutorial, and then in the root directory of the GitLab project, I'll go into source. So we have a POM file, and then we have the source directory. And in the source directory, we have it separated out by the test directory, and then the main directory, which contains a single class called app. And inside of the app class, it simply prints out hello world to the console. And then if I go back to the test directory, we have a single test class called app test. And if I open that up, we have a JUnit test test class, and then a single test case within that test class. In this test case asserts true on a condition that is always true. So this test case will always pass unless we were to change this condition to false. And that's pretty much all there is to this code base. It's very straightforward. So let's navigate back to the project homepage. So to define a CI/CD pipeline for a GitLab project, you need to create a YAML file at the root directory of your project, and its name should be .gitlab-ci.yaml. And there's two ways that you can create that file. You can either create it from the drop down here, so you could just create a new file and call it .gitlab-ci.yaml, or you can create it from the CI/CD section, and they have a dedicated section for editing and creating GitLab pipelines. I think that the best method for creating pipelines is using the pipeline editor, and I'll show you why. So I'm going to select editor, So this will create a pipeline on the main branch, and it says create a new .gitlab-ci.yaml file at the root of the repository to get started. And then I can create a new CI/CD pipeline by clicking this button. So I'm going to select it. And on the right-hand side, we have this help section for getting started with GitLab CI/CD. I'm going to close this out, but before I do, I'm going to open up this link for viewing its syntax reference document that GitLab provides. I'm just going to open that up in a new tab because we may refer to it later on. Okay, and after I've opened that up, I'm going to go ahead and collapse that help section. And when we open the editor for the first time, GitLab automatically fills out this template pipeline definition for a very basic pipeline. And in the pipeline definition, there's 3 stages defined. So here's a stages statement. And then under that statement, we have a build stage, a test stage, and then a deploy stage. And this isn't the only pipeline template that GitLab offers. You can see up here it says browse templates. But if I were to open the pipeline section up in a new tab, if I scroll down, you can see a list of CI/CD templates based on your technology stack or the framework that you're using. And there is a template for just about every technology that you can think of. You have Golang templates, Flutter templates, Gradle. There's even a Maven template for Maven projects, but we aren't going to use this template. And we also are not going to use the template defined here as well. But the pipeline definition that we'll write is going to be from scratch, and it will closely match this structure where we have a build, test, and deploy stage. And under the stages definition, they define the jobs. And the first job here is the build job. And you don't necessarily have to follow this naming convention. You could just call this build if you wanted to, but it does make it clear when you add the hyphen job to the statement. And then to associate a job with a particular stage, we would just use the stage keyword here. And then the value would be the name of the stage that we want this job associated with. And after associating the job with a particular stage, we can then specify a shell script that would be executed by the GitLab runner. So if I hover over any of these keywords, it gives me a definition of the keyword. And you can see here for the script, it says these would be shell scripts executed by the GitLab runner. And it is the only required property of jobs. So under the script statement, they have 2 echo statements where they're kind of, pretending to compile a code base, right? And then under the build job, they've defined a unit test job, which is associated with the test stage, where they run unit tests, and then a lint test job that is also associated with the test stage. So there are 2 jobs associated with the test stage. And then the last job is the deploy job, which is associated with the deploy stage. Now, one thing I want you to notice about using the pipeline editor is at the top, it says this GitLab CI configuration is valid. So when we use the editor, one of the benefits of using the editor is that GitLab, while we're editing the pipeline, GitLab is checking and validating the pipeline syntax and the configuration to make sure that it is actually going to run. In addition, we also get these tabs here, the Visualize, Lint, and View Merged YAML tabs. If we look at the Visualize tab, it gives us a graphical version of our pipeline. So now you can see that the build job is associated with the build stage, the test jobs, the unit tests and the lint test jobs are associated with the test stage, and the deploy job is associated with the deploy stage. By default, when multiple jobs are associated with a single stage, those jobs will be executed in parallel. And then on the lint tab, it gives us some information on the parameters and properties of our pipeline definition. So here it also says that the syntax is correct and the configuration is valid. And then for each of the parameters in the pipeline, it gives us some properties associated with that parameter. So you can see here all of the jobs are listed. And then in the value, we have these properties also listed under the value. So for this first property, we have the only policy, and its value is branches and tags. And this policy is referring to the only keyword that you can use in a pipeline definition. So if we take a look at the keyword reference, we have only and except keywords, and you can use only and except with 4 other keywords: references, like get references, pipeline variables, changes, and also Kubernetes. And these keywords control if a job will run in a pipeline, because if I use references, for instance, I can specify specific get references. So only run this job when the get reference matches a particular regular expression. So for instance, only run this job if it's a particular branch, like the main branch or a feature branch, and that can be a regular expression as well. So it can be like any branch that starts with a Jira issue ID, for instance. So going back to that pipeline definition, if we take a look at the value here, branches and tags, this job will run when the get reference for the pipeline is a get branch or a get tag. And then below the only policy, we have the when keyword, and its value is on success. And this specifies a conditional. The when keyword specifies a conditional. So when should you run this job? Only on success of previous stages. So this is only going to run if prior stages have passed successfully. Otherwise, if a earlier stage has failed, this job will not run. And this is the default value for this condition. So we didn't have to explicitly set the only keyword or the when keyword in that pipeline definition, because this is the default behavior. Jobs will only run when prior jobs have passed successfully, unless you change that, you explicitly change that condition. Okay, and then on the last tab, we can view the merged YAML file. Okay, so this is just a view-only version of the YAML file without the comments. And then I'm going to navigate back to the Edit tab. Okay, so let's start editing this template so that it works for our Maven project. So I'm going to delete all of these comments here. And like I said before, our pipeline definition is going to be similar to this one. So I am going to keep the stages definition, and I also will keep these jobs, but I'm going to clean it up a little bit. So I'm going to delete the extra echo statement. We'll keep that lint test job. Then we'll keep the unit test job as well. So now we can start adding our own stuff to this pipeline definition. And the first thing that I want to specify is the Docker image that the GitLab runners should use when they execute jobs in this pipeline. So if your project has dependencies that need to be installed for it to be able to compile the code base and run tests on the code base, you can specify a Docker image that includes those dependencies, and the GitLab runner will use that image to actually execute all of the steps defined within your jobs. And to specify the image, it's very simple. At the top here, I'm going to use the image keyword. And then after specifying the image keyword, we would provide a value. And that value is going to be the name of the Docker image that we want the runner to use. And in this case, we're going to use the Maven image, which includes all of the dependencies that we're going to need in order to compile and test and run our Maven project. So after specifying the Maven image name, I'm going to specify the version, and in this case, I'm just going to say latest. So I'm going to use the latest Docker image for Maven. So now that we've defined the Docker image that should be used when running these jobs, the next thing that I want to define are variables. So we can define pipeline variables inside of our pipeline definition using the variables keyword. And what should be our variables for this pipeline definition? Well, we're going to have two variables. The first is going to be called Maven CLI options. And the only option that we're going to pass to Maven is the -- batch mode. And this will run Maven in a non-interactive mode so that it won't prompt interactive mode And now that I've defined this variable, I can reference it in any of the shell scripts that I define in any job in the pipeline definition. And I said that there were two variables, and the second variable is going to be called Maven options. Okay. And we're only going to pass in one option, and that's the location of the local repo. So I'm going to say -d-maven.repo.local is equal to, and then I'm actually going to reference an environment variable that is known as a predefined environment variable. And it's called CI_project directory. So we don't have to explicitly define the value of this environment variable because it's predefined by GitLab. Okay, so within the project directory, we will specify the .m2 folder and then repository. And I think the GitLab configuration validator is complaining about a couple of things that I've done here. If I hover over the yellow squiggly line, it says cannot read an implicit mapping pair. I think the first thing is this extra quotation mark, but also I've used tabs here, and I think I should be using 2 spaces. So I'm going to do 1, 2, and 1, 2. So now that we've defined those variables, the next thing I want to do is utilize GitLab's built-in caching feature for its pipelines. We can actually cache artifacts of a pipeline run to speed up future runs of the pipeline. And to do that, we simply need to specify the cache keyword. And then after using the cache keyword, we would then specify the paths within the project that we would like to cache. And in our case, it's really important to cache the Maven dependencies because otherwise the Maven dependencies will be re-downloaded for each job that runs. So below the paths keyword, we can specify the path that we want to cache, which is going to be .m2 and then repository. Okay, so now that we're caching the Maven dependencies, we can move on to the build job. And under the build job, I'm going to leave this echo statement, but I'm going to add one more shell script. And here I'm going to invoke Maven with the CLI options. So I'm going to reference the variable that we defined. So Maven CLI options, and then we will use the compile command. And that's all we need for the build job. So I'll scroll down to the unit test job. And again, I'm going to add one more shell statement. And this is going to be Maven. And then we will use the Maven CLI options again. And then we'll invoke the test command. Now, one thing that is really cool is that GitLab can actually render JUnit test reports, and all we have to do is generate those test reports as artifacts. So under the script statements, I'm going to specify the artifacts keyword. When we use the artifacts keyword, we can specify a path that contains artifacts that we would like to persist beyond the length of the job. So after the pipeline has finished, any paths that were specified as containing artifacts, those items will be persisted after the pipeline finishes. So we can access those artifacts and download them from GitLab. And in this case, we're storing JUnit reports. So the first thing that I want to specify is when these artifacts should be generated. And I'm going to say that they should always be generated. And then under the when condition, I'm going to specify the reports keyword. And under reports, I'm going to specify JUnit. Okay. And under the JUnit keyword, we can specify the path to our JUnit reports. And that's going to be under the target directory, Surefire, reports, test, and then any file with test-.xml. Okay. I'll also do this for the failsafe reports. So I'm going to do this. Okay. So now that we're generating those JUnit reports as artifacts, we should be able to download those reports after the pipeline finishes. And then also we will be able to, those reports will be rendered within the GitLab UI. So you'll be able to see what that looks like once we run this pipeline. Okay, so after the unit test job, there is the lint test job, and it's not doing anything, but I am going to leave this job there so that you can kind of see that the job runs in parallel. And then after the lint test job, we have the deploy job. For the deploy job, we won't actually deploy the application to some remote server. What we'll do is we'll just use Maven package, and then we'll run the application locally. So under the echo statement, what we're going to do is invoke Maven, and we will invoke it with our CLI options. And we're going to invoke the package command. And finally, after invoking package, we will run the program using Maven, and then we'll reference the CLI options, and then we'll say exec java-d exec.main class is equal to com.mycompany.app, and then the app class. So when this command is ran, we should see hello world printed out to the console of the job. Now, the last thing that I want to add to the deploy job is the environment keyword. So we're going to add an environment to the deploy job, and it will be the staging environment. So this deploy job is going to, quote unquote, deploy our Maven application to the staging environment. And what that is going to do is it's going to create a deployment under the deployment section in the environments page. So we'll take a look at that after the pipeline has ran. Other than that, I think that's pretty much everything that we need for this pipeline. So all we need to do is commit our changes to the file. And as soon as we make a new commit, the pipeline will run. So I'm going to select commit changes. And it says that it's currently checking the pipeline status. And in a little bit, it should show up with a link to the running pipeline. There we have the link to the running pipeline. So I'm going to go ahead and select that and open it up in a new tab. So when we navigate to the pipeline tab, we can see the status of each job in each stage. And you can see under the testing stage that both test jobs are currently running in parallel. And the build job has already completed successfully. So now the deploy job has begun, now that both of the test jobs have completed successfully. And this pipeline run should take a little bit longer because on the first run, the cache is empty. So we haven't cached any of the Maven dependencies. So after this run, the pipeline run should be a lot quicker. And now it looks like the deploy job has completed successfully. So the whole pipeline has completed successfully. Let's take a look at each one of these jobs. So I'm going to open up the build job in a new link. And when we open up a job, we get the console output of all of the commands that we defined in the job definition. So up at the top, we can see that the job begins. It's running with GitLab runner. And then after that, you can see that the GitLab runner is pulling the Maven, the latest Maven Docker image, so that it can run the job within that Docker image. And it's really convenient. Next to each of these statements, you get the time duration for how long that particular command took. And in the top right, you can also see the total duration of the job, which was 44 seconds. The timeout period is set to 1 hour, and that simply means that if at 1 hour the job is still running, that the job will automatically be canceled because maybe it's the job is hanging for some unknown reason, and you don't want to utilize all of your runner resources on a job that's hanging. So if we scroll down further in the console, we can see that the runner clones down the code base, and then on line 30 it checks the cache for default, and it says fatal file does not exist. So there is no cache because this is the first run of the pipeline. And then on line 36 we can see the first shell statement of our build job, where we say we're compiling the code. We invoke Maven compile with the CLI options. And then starting at line 44, you can see where Maven begins downloading all of the Maven dependencies. So what I'm going to do is I'm going to scroll down below where it's downloading those dependencies. And after it downloads the dependencies, it compiles a module, and we can see that it was a successful build, and it took a total of 8 seconds. And since the job was successful, you can see at line 393, it's saving a new cache. And on 395, we can see that it caches the .m2 repository directory, and then it uploads that zip file to essentially back to GitLab. So now that we've seen the build job, let's take a look at the test job, not the lint test job, but the unit test job. So I'll open that in a new tab. And here, if I scroll up to the top, I'm going to use this button to scroll to the top. We can see roughly the same output as we did in the build job, where it's preparing the Maven Docker image to execute our Maven commands on. So starting on line 36, we can see where our unit test job begins, and then we invoke Maven with our CLI options and then the test command. Okay, and then it downloads the necessary dependencies. And then if I scroll down below that, we can see where the tests actually get executed, and 1 test ran and there were 0 failures. So we get a successful build, and then below that you can see here it saves the cache for the successful job, and we can see that it's caching the .m2 repository directory. Now below the cache creation, starting at line 211, you can see where it's uploading the artifacts that we created. And the artifacts that we generated, remember in the pipeline definition, were the JUnit test reports. And it identifies the Surefire reports directory on line 211. There were no fail-safe reports, so it says that there were no matching files there. But it did find one matching file for the Surefire test reports, and it uploaded those artifacts as a JUnit test report. So we'll take a look at those test reports in a little bit, but first I'm going to go back to the pipeline, and let's open up the deploy job, and let's quickly walk through the deploy job as well. So I'm going to scroll up using the scroll to top button. And then again, we have a very similar output as we did in the previous jobs. It clones down the code base. It recognizes that there is a cache, and it downloads that cache and it extracts it. And then the Maven package command is invoked. So it then downloads the necessary dependencies, and if I scroll down, you can see it's running running the tests again. And then if I scroll further, it packages the program as a jar file, and then it runs the exec command on the main class. Okay, and then it downloads more dependencies. And then if I scroll down to the bottom, you can see where on line 250 it actually runs the app class, and it prints to the console hello world. And then finally on line 258, you can see that it creates a new cache. Okay, and then the job finishes. So now that we've looked at the job output, let's navigate back to the pipeline tab. And on the pipeline tab, we can see several tabs here: the pipeline, the overall graphical view of the pipeline, but then we also have this test tab, and we can see that there is one test. So if I open this test tab, we can get a summary of the tests that pass, and this is generated from the JUnit reports, and it shows us which jobs are associated with those tests. And if I wanted to download these test reports, I could simply go back to the pipelines page, which will show me a list of all of the pipelines that have ran. And you can see the pipeline that we just ran over here on the right. It shows me an artifacts dropdown, and I can actually download artifacts that were generated by the pipeline. And in this case, there was only one set of artifacts, which was the JUnit test reports. And in addition to the artifacts, I also specified an environment in the deploy job, and that should have showed up under the deployments. So if I go to deployments and then environments, we can see that there is one environment, the staging environment, and there is one deployment to the staging environment, and it shows the job associated with that deployment and the commit as well. If I wanted to see a list of all of the jobs that have ran, I can go back to the CI/CD section and select jobs, and this will show me a list of all of the jobs that have ran in the past. You'll also notice that under the jobs section, we can create schedules for our pipeline. So if I select new schedule, I can specify an interval pattern or a cron pattern to run our pipeline, maybe like every day or every week. So that's also a useful feature that we can use for our GitLab pipelines. Now, a few more things that I'd like to show you are in the settings. So if I go to settings and then CI/CD, we can update various settings related to our pipeline. So if I expand the general pipeline configuration, I can actually specify a custom path for the pipeline definition within the project. I can also change the timeout period for jobs that fail if they run longer than the timeout period. And then below the general settings, if I collapse this, you have auto DevOps, and if you turn this on, GitLab will attempt to like automatically set up a pipeline based off of your project's technology, like whether it's a Maven project or a Golang project or something like that. Under auto DevOps, we can configure GitLab runners, and right now I've been using shared runners, which are hosted by GitLab. And under shared runners, I can see all of the runners that are available to me that I can use. However, if I didn't want to use shared runners and instead I wanted to host the GitLab runner program on my own infrastructure, I could register my own runners with this GitLab project so that in the pipeline definition, I can assign jobs to those runners that are hosted on my infrastructure. And then under the runners configuration, we can also define pipeline variables at the project level here as well. So if I expand the variables section out, I can create new variables, and these variables that I create can be protected and masked. So protected variables can only be exposed to protected branches or tags, and then masked variables are hidden in job logs. And this is useful in the event that you have environment variables that would be passwords. So for instance, if you're trying to upload an artifact to Artifactory and you need to authenticate with your Artifactory instance, you would need the username and password for the Artifactory user. In that case, you can use a masked variable for the Artifactory password. So if I were to select add variable, I can specify the key of the variable like Artifactory password, and then the value of the password. And I can specify the type and the environment scope, and I can protect it. And then I can also mask the variable as well. If I added that variable, you can see that the value here is not visible. But if I need to, I can still reveal the value using this button. And the last thing that I'd like to mention are pipeline triggers. So you can trigger a pipeline for a branch or a tag by using a trigger token. So a use case, a sample use case for this might be if you wanted to trigger a pipeline to run via a Slack command. So if you had a Slack bot, you can provide the token to the Slack bot so that the Slack bot can communicate with the GitLab API and trigger this pipeline to run. So I'm going to navigate back to the CI/CD pipeline section. And I think that wraps up everything that I wanted to cover in this particular module. So I hope you enjoyed this video, and I will see you in the next. If you'd like to learn more, be sure to follow our blog at lambdatest.com/blog, as well as our LambdaTest community at community.lambdatest.com. You can also earn resume-worthy LambdaTest Selenium certifications at lambdatest.com/certifications.